Hello everyone and welcome back. If you're into machine learning, deep learning or building real systems and you're curious about doing all of that in Rust, you're in the right place. Machine learning today is dominated by Python, and don't get me wrong, Python is amazing. But here's the question this channel is built around. What happens when machine learning moves from notebooks to production system? That's where Rust enters the conversation. Most machine learning tutorials stop at training a model, plotting a loss curve, saving a checkpoint. But in the real world, models run on servers, run concurrently, handle real user traffic, must be fast, safe, and cheap to operate. That's exactly where Python starts to show some cracks and where Rust starts to shine. So in this tutorial here, I'll be taking you guys from the basics and fundamentals of machine learning in Rust. We'll be exploring some machine learning algorithms in Rust and the toolings available for those. We'll be building neural networks from scratch in Rust with the available toolings. And at the end of the session, at the end of this video series, we should be able to build and deploy production level machine learning systems and see the gains we have doing that in Rust compared to Python. So without any further ado, let's just get to it. We give a great thanks to the Rust community for bringing together these resources on this website, Are We Learning Yet? So on this website here, we have everything we need to know in order to get started with machine learning in Rust. So we're not going to go far, we're just going to get to the documentation of the website here and see what we need to get started with machine learning in Rust. So the first question we should ask ourselves now is, why machine learning in Rust? And the answer is pretty obvious. And it says here, Rust performance, low-level control, and zero-cost high-level abstraction makes it a compelling alternative to more established ecosystems for machine learning. While the Rust machine learning ecosystem is still young and best described as experimental, several ambitious projects and building blocks have emerged. So this already tells us why Rust is a top goal for machine learning. So not to be biased and reading everything from the Rust website, let's go to another website I found online having nothing to do with Rust. So let's go to it and see what it says. Here it says why Rust is essential in AI and systems programming. 1. Speed. The compiled language Rust is made to perform similarly to C, but Rust builds straight into machine code, unlike Python, which requires an interpreter. Additionally, this enables Rust to provide consistent performance with no overhead. Beautiful. 2. Memory safety without a garbage collector. Rust ownership concept is one of its most popular characteristics. Strict limitations are enforced throughout the building process to avoid issues like data races and dangling pointers. Rust guarantees memory safety without needing runtime overhead, as contrast to languages that depend on a garbage collector, Python. Concurrency and parallelism. Concurrency is often a bottleneck in AI app programming. Moreover, Python's global interpreter lock makes true multi-threaded difficult. This prevents it from making the most of contemporary multi-core CPUs. On the other hand, concurrency was designed when building Rust. Good. Growing AI ecosystem. Although Python dominates AI libraries, Rust ecosystem is rapidly expanding with promising tools such as NDRA, LintPy, TouchRS, Rust NumPy, which we are going to see in a while. Reliability in production environments. Rust is particularly valued in systems programming, where reliability is paramount. AI models often move beyond research environments into production systems that must be fast and secure. Also, Rust's design philosophy, fearless concurrency, and memory safety directly addresses these needs. For example, HAI, cloud and high performance systems, embedded AI. So I think this is a lot of reasons for why we should go for machine learning in Rust. So let's come back to the side here. So now that we know why machine learning in Rust and we have seen the differences or a comparison between Rust and Python when it comes to machine learning, let's dive into the available toolings and the ecosystem you have available for learning machine learning in Rust. So down on the website here, we see the available ecosystem. They are classified here into a catalog and into categories where we have clustering, data to scientific computing. So we're just going to zoom into each of these catalogs here to see the available toolings we have available then. So clustering here, coming to clustering. So Rust does not it's a little bit shallow on the various on clustering algorithms here, meaning the crate here implement just few of the clustering algorithms for now. We have k-means, we have dbscan, and we have optic clustering algorithms which are implemented among these crates here. As you can see, there are a lot of them. There are new crates like ones which are still on implementation. There are production ready ones such as Linfa, and there are still others which are still in dev stage which has not been mentioned here. But this website is kind of open for anyone who wants to add any missing crate. You can directly create an issue here and create the issue and add the crate you think it's missing on this website. So since there are a lot of crates here, I'm just going to go into three of my best or the general best crates which are available for the task. For clustering here, Linfa stands out as the best because it has a lot of tooling and it's similar to Python's skitlearn. So the course here are a little bit similar to that of Python's skitlearn. For those who have done machine learning in Python, you will have you enjoy using Linfa. We have smart core too. I've not used smart core enough, but I heard it's also good because it's fast economic. It's a fast economic machine learning library for us, covering supervised classification and unsupervised classification methods. So it's actually cool. And you have k-means color. It calculates the k average colors in an image using the k-means clustering. So those who love colors and painting, you enjoy using the k-means colors library. So I'm just going to stop here for the clustering, but I'm going to drop the link to this website in the description of the video. In case you want to explore more of these crates, you can just go there and explore them. There are pretty much of them. So moving to the next category now, we have data processing. And here we bring out the various scripts Rust provides for processing data. We have CSV here, which is a fast CSV passing with support for SEDI, serialization and deserialization. Moving to the next now, in the data structure category. In the data structure category here, we have the various libraries which are needed to perform numerical operations and data structure operations. So we have num here. Num is a collection of numeric types and traits for us. It's used for operations on numbers. I love num. It's very easy to use and it's spelled directly by the Rust language. ND array or n-dimensional array for general elements and for numerics. Lightweight arrays use and slicing. Since data through a neural network are just arrays, the ND array stands out as one of the best libraries for generating vectors which are fed into a neural network. So personally, I love ND array, num, polar, pet graph. I've not used pet graph, but I think it should also be cool. We have decision trees. Linfa stands out. We have smart core, we have XGBoots, and we have Rosslyn. All of these scripts, we are going to explore them in details when we will be building our neural networks. We are going to see their usage and which one is best for which case. So nothing to shout out for now. No need cramming all of these scripts. We have GPU computing. We have WGPU. We have Volcano. we have Kodak, Blast, and all the rest. So for now, we just need to know they exist, and later on we're going to use them. No need cramming, as I said. In the linear classifier section, we still have LinPar, SmartCore, DFDX, Roslen classifiers. For the meta heuristics, we have ArcMin. So meta heuristic aims to generate or select a heuristic for an optimization problem, particularly when a set of sample solutions is too large to completely sample. A handful of meta-heuristic traits exist in the ROS ecosystem, most notably several libraries that make it straightforward to write generic or evolutionary algorithms. You have ACMIN, numerical optimization in pure ROS. And there are a lot of meta-heuristic traits here in ROS, a lot of them, a lot. So coming to the machine learning ops, ML ops category here, we have quadrant here. So let's just read what they say about machine learning operations. Machine learning operation combines machine learning, DevOps, and data engineering into streamline and automate workflows for machine learning models, development, deployment, and maintenance. Rust is gaining popularity in machine learning ops for its performance, safety, and reliability. It's used to build efficient machine learning infrastructure, data processing pipelines, vector databases, and model serving systems. Rust speed and memory safety makes it particularly suitable for high performance, mission critical machine learning ops component. We have Quadrant here. Quadrant is a widely known vector database and vector search engine, and is built in Rust. We're going to use this one. Will be deploying one of our machine learning systems. It's very interesting. Neural networks. So while native Rust deep learning libraries have made progress, they are still largely experimental. However, there are high quality bindings available for both TensorFlow and PyTorch. We have ORT, a safe Rust wrapper for Onyx runtime, optimized and accelerate machine learning inference and training. Onyx is an open neural network exchange. It's an open source format for models that enables interoperability between machine learning frameworks such as TensorFlow, PyTorch. It allows models to be trained in an environment and deployed in another one. So ORT here is a safe wrapper over Onyx. We have Torch. Torch wrapper is a Rust wrappers for Torch C++ API, meaning it's PyTorch. It's the Rust Torch for PyTorch. We have Candle Core here. Candle is a minimalistic ML machine learning framework with CUDA acceleration and optimization support. Candle is pretty good, easy to use for those coming from the Python world. I've used Candle and it's very easy to use. We have Burn. Burn is a flexible and comprehensive deep learning framework in Rust. Burn comes to be one of the most complete machine learning frameworks. It's built directly, natively in Rust, so it's fast and it has support for most backends. For example, as you can see on the table here, NVIDIA with CUDA supported, NVIDIA with Vulkan supported, NVIDIA with Web GPU supported. So it tries to have a lot of support, and it's a very fast framework. It also has a dashboard for visualizing once you're in the training phase. So for those wanting to build, and also it has Onyx support, training dashboard, importing PyTorch or safe tensor models, inference in the browser, embedded no STD support. So Burn here stands as one of the best. So for those wanting to build powerful machine learning application, I would deeply advise you to use Burn as it's complete and very fast. So we also have TensorFlow here, which is the Rust language binding for TensorFlow in Python. So for my best here, I used Burn, Candle, ORT, Touch, and also TensorFlow. We should try them, and we're going to try them, all of them, I mean most of them, once we'll be building our machine learning systems. So we now come to natural language processing. Natural language processing here will bring out the crates in Rust we use for natural language processing. We have RustBERT, we have LLM chain, and we have LLM. LLM here is a Rust library unifying multiple machine learning language, large language model backends. We have transformers and interface for AI APIs. Okay. And then now in reinforcement learning is a branch of machine learning concerned with sequential decision making problems. That is, this is a branch where we reward a model when it does it actually does what we want. That is, for each good action does, it gets a reward, and for each bad action does, it deducted some points. So that's that's the branch of machine learning called reinforcement learning. So the libraries we have available for reinforcement learning in Rust, we have TFTX, REL, RSRL. So and you see the support here, and you see they are widely loved by on GitHub. 1.9k stars, 160 stars, pretty good. And for scientific computing now, we have several crates available for scientific computing. We have N algebra, matrix multi, elite, stars, CGMAT, pretty good. So we're going to use most of this crate, and not all, we can use all. We're going to use most of this crate in the next tutorials, where we'll be building neural networks and building even some classification algorithms, and using some crates, seeing how they implement classification algorithms to build a classification network or machine learning system. Okay, I'm going to drop the link to this. I hope you had like an understanding of why machine learning in Rust, the comparison between Rust and Python when it comes to machine learning, and the available ecosystem Rust provides for machine learning. So let's meet in the next one.